HNMR Example. Let's take a look at this. We got some things shifted up to 4 and then 1 down here for this messy looking structure right there. So what do we do with this? Well, I noticed one thing here. Notice how it looks like 4 peaks right here, but I think that's actually the overlapping of 2 different types of peaks because they should always look symmetric. This to me looks like a singlet, and this here looks like 1, 2, 3, and there's a hidden 4th peak here. This looks like a quartet. So actually we have a quartet, a singlet, and a triplet. Let me show you a little trick here that you commonly see. If you ever see a quartet and a triplet in the same NMR spectrum, it's likely that you have an ethyl group. Let me show you what I mean. Doesn't have to be, but it's often a good sign of it. So for example, if you have an ethyl group and there's no hydrogens over here, okay, nearby, so you'd have, this would give a quartet. Okay, so that would be this peak right there. Because it's near to 3 hydrogens, you add 1, that's 4. This one would give a triplet, because it's near 2 hydrogens, you add 1, that's a 3. So that would be that one. So whenever you see a 3-4 peak splitting combo, I often think ethyl, though it doesn't have to be that. But it's definitely worth a check if you see that. So that'd be a C2H5. In this case, if we have this and we minus C2H5, kind of just to work backwards here, that would be a C2, what's left? Then 2, C2, 2 H's, O, 2, Cl. Is that right? Okay. I think that's a little messy, but I think I got that all together there. Now, what's left, we have a singlet. That's probably caused by this mess here. So it looks like I probably have something like a CH2 from this one. Remember, this is a quartet, so this is the CH2 of the ethyl, and this is the CH3 of the ethyl. At least that's my current guess right now. Alright, so I think this is giving a singlet because it's not next to any other hydrogen, so I don't think this is near the ethyl group, or it would mess up the ethyl pattern of the 3-4 peak. So I think that's all by itself. It's shifted way high. So notice there's oxygens and chlorines. I think one of these is near an oxygen and the other one's near a chlorine. Okay? Because both of those would shift something over. Now we have an extra oxygen. We have so many oxygens here. I'm kind of thinking we've got something like this. Some sort of ester probably would do it. Some sort of ester that has a chlorine on it. That seems to make the most sense. So I can, if I mess around down here, if I put the ester like that, I could put, if I put the ethyl group here, and I could put a CH2 and a Cl here, or I could do the opposite. I could do one of those 2 situations, because the CH2 by itself in either case would give the singlet because it's not next to anything, and singlet is the least amount of peaks you could have. This in either case would give the 3-4 peak splitting pattern. And in both cases, these have the right number of carbons for, they have the right number of hydrogens and oxygens and chlorine. So everything's looking good so far. We just need to figure out which one it is. I think in this case, if that were true, this would be very highly shifted, maybe even above 4, because it's next to an oxygen and a chlorine. It's like double duty. And this one wouldn't have to be as high, because it's a little bit removed from the oxygens. It probably wouldn't be at 4, it'd probably be more like at 2. So I'm preferring this one here. Again, because this would be like, I think even more than 4 shifted up, and this would be less than 4 for this part right here. I think this quartet would be lower if it's like this because it's so far removed. But if it was here, okay, this is next to the chlorine, that'll put it about 4. Usually next to something like the oxygen or chlorine, whatever, puts you around 4, 3 to 4 range. Here, this is next to oxygen, that puts this one around 4. This one's not that close to oxygen, that's why it's so normally shifted here in the pretty typical alkane range below 2, somewhere around 1. So it looks like this is the structure right here.